Hi everyone, welcome back. So this is the 14th video in this series where I am using the R programming language and RStudio to conduct data science tasks and data analysis. So in the first 13 videos I've recorded so far, I focused on kind of introductory basic information around installing and setting up RStudio, and then a number of videos focused on kind of just getting started with some of the basics around tidying and wrangling data to get it into that tidy format, predominantly using the tidyverse and a number of packages. So there's so much more I could cover in relation to that, but what I thought I would do is move on in this video and the next few videos, and we'll start talking about data visualization, so creating figures and plots to explore your data. Okay, so what I'll do in this video is basically start by demonstrating how you can use ggplot to create scatterplots. So you probably remember, I've mentioned it in other videos, that ggplot it's a package for creating data visualizations, and it comes under that tidyverse kind of umbrella package. And ggplot uses something that's referred to as the grammar of graphics, GG, essentially. And that's a useful syntax for allowing us to create data visualizations and figures and build them up layer by layer by specifying the axes, specifying the variables we want to plot on the axes, things like that. So the basic syntax for ggplot requires that we specify the data we're going to use, then the aesthetic mappings, the mappings or aesthetics of the plot. So that would be the variables that we're plotting, and thirdly, the geometries. So that would be given our axes, given the variables we want to plot on those axes, how is the data going to be represented? Is it a scatter plot? Is it a box plot, etc. So what I'll do in this particular video, just to get started, is I'll use a built-in data set to create a scatter plot. We'll start really simple, and then we'll add elements to make it look a bit better and more complex and more professional. So in a previous video, I kind of mentioned that I'd had some computing issues, and the project that I'd set up for these videos was no longer working. It seems to be corrupted. You can see at the top here, where my cursor is there, project is shown as none. So what I've been doing the last few videos is just on a script by script basis, just saving them in a particular folder on my worktop, on my desktop. What I will do is, at some point I should create another project, and I can use that to save the scripts for these data visualization videos. But what I will need to do first of all, so I've got this particular script that I'm using here, this one here in the top left, in the correct folder on my computer, is I need to set my working directory because I'm not working in a project. So to do that, you've seen me do this before, I believe. I'm going to use this setwd command, and then in parentheses, as a string contained within double quotes, I'm going to pass the relative path to this particular folder, our data wrangling, on my computer. So if I run that command, you can see it's executed here in the command line below in the console, and it has worked. We know it has worked because the relative path here has changed, and it's now showing the folder that I'm using is this R data wrangling folder. So the next thing I'm going to do is I'm going to use the tidyverse, because our ggplot is contained within that umbrella package of the tidyverse. So if I do Control and Enter and run that, that should, you can see library tidyverse as executed, and it's kind of still working. It's still thinking about it, still loading that, but we should see that work in a second. There you go. So you can see the various packages contained within the library, within the tidyverse package or library. And then they've got some notes about conflicts where certain functions or methods have the same name in multiple packages. It's just something to be aware of. So what I'm going to use in this video is a data set about penguins. It's quite a famous data set. It's called, sometimes referred to as the Palmer Penguins data set. It's a data set that was recorded some time ago, and it's recordings of 3 different species of penguins on 3 different islands in the Antarctic, and it's got measurements around kind of body size, weight, things like that. The data set is contained within a package called Parma Penguins that you can load into, you can install into the packages in RStudio. So to do that, you'd need to run this command here, install.packages, and then in parentheses, as a string within quotes, specify the package name Parma Penguins. I've already got it installed, so I'm not going to run that. I'm just going to comment it out. But I am going to load that package, so I'm then going to use the library command and load Parma Penguins. If I do that, that has worked. You can tell, I can tell that's worked because it's run the command and then it's returned my command line prompt below, as you can see there where the flashing cursor is. So to call this particular data set, if I use this command here, penguins, it'll display a little data tibble, like a little data frame, showing some of the variables and some of the data contained within this particular data set. So I've just run that, and there you go, it's printed that to the console below. And you can see here we've got a number of variables. We've got 344 observations, 8 variables. We've got species, Adelie, I think the others are Chinstrap and Gentoo, island, Torgenson, there's a couple of three, I think there's 3 different islands. Then we've got these numeric variables, bill length, bill depth, both measured in millimeters, flipper length, millimeters, body mass in grams, sex, male, female. So quite a useful data set for what I'm going to do here, creating a scatterplot, because we've got these numeric variables. We've also got a couple of categorical variables there in terms of species, island, sex. We've also got some missing data, which will be interesting to see what happens with that when we try to create plots using ggplot. So let's create a basic scatterplot recording flipper length and body mass. So to do that, first of all, I'm going to call the ggplot function or method. So I'm going to specify ggplot and then open some parentheses. And then the 3 things I said previously you need to specify are the data, the aesthetic mapping, which would be what we're mapping onto what axes, and then the geometries, what we're going to use to represent the data points. Okay, so that'd be a real basic thing to get us started with. So I'm calling ggplot, and then within ggplot, I'm opening these parentheses. I'm specifying the data we want to use is penguins. The mapping, I'm using this mapping argument. I'm saying that equal to AES. That's short for, I think that's short for aesthetics. And then in parentheses inside that, inside this kind of ggplot call, I'm saying what I want to plot on the x variable, flipper length in millimeters, then a comma, and what I want to plot on the y variable, body mass in grams. Okay, then I'm closing that initial call to ggplot there. I'm closing that with a second parenthesis, so you can see the area I've highlighted so far. And then outside that, I'm putting a plus sign, and then I'm adding G on point. So if I ran the text that's highlighted here, the syntax, ggplot, the data, the mappings, what's going on the x and y variable, it returned a plot with some axes and these labels, but no data points. So we then need to specify how we want to represent the data, and that is using these geometries. Okay, so I'm using a plus, and then I'm saying geom point, which is basically saying plot the data, plot each data point as a dot or a point, so a scatter point, essentially a scatter plot. If I run Control and Enter, you'll see what that looks like. And there you can see in the bottom right, we flipped us over to this Plots tab, and you can see we've got a nice scatter plot of this data set. So it's got flipper length on the x-axis, body mass on the y-axis. It's selected the scale, the values for the scales, the start and end values automatically for us. We've not had to specify that. We can change that. We can change those sorts of arguments if we want. But it's chosen the kind of defaults that I think it best represents the data. And you can see each observation is represented by a dot in black. And you'll notice here, if you look in the console in the bottom left here, we've got this warning message, and it says it's removed 2 rows containing missing values. So we did know we had some missing values, because we could see, if I scroll back up to that till we can see we've got a lot of NAs here, missing values. And what has happened here is this package has been created by someone, and in the background it is automatically taking care of some of the details for you. So it is dealing with issues such as missing data without you having to actually remove them first and then plot again. Okay, so it's kind of making our lives easier. So it's a useful package. This is one of the good things about something like ggplot. Okay, so that's a real basic scatterplot to get started visualizing our data. But we could add some aesthetic detail to this plot to make it more informative. We could differentiate between these three penguin species by setting the color parameter to map each species separately. Okay, so if we do that, ggplot will just use a default color palette and it'll provide us with a legend as well. So in this data set here, if we look at our plot, all these black dots, there are three hidden in here somewhere. There are three different species, and we can use this color argument to separate out, represent the species by different colored dots. And you'll notice to do that, I'm specifying ggplot again. I'm saying we want to use the penguins data again. Our mapping is pretty much the same as before in terms of we're saying statics, and then X we're going to flip a length, Y we want body mass. But notice here we've just added this extra argument. So color equals species. Okay, and then we've still got our plus geom point with the type of geometry we want to use. So let's run that. It'll give us another plot, a second plot, and there you can now see it's given us a legend. It's representing each species using a different colour, and we can see straight away that the species with the larger flipper lengths and higher body mass all appear to be this blue colour, which are Gen 2, so obviously a much bigger species than the other two that are kind of similar in size. Okay, so that's quite useful. There's lots of other things we can do, and I'll just demonstrate some of them here. So we've got a scatter plot here. We've got scale variables represented against each other as X and Y. We could, if we wanted, fit a linear model to this. So we could overlay a regression line on our plot. We can do it for each species or globally. I'll demonstrate how we do it for each species. So to do that, what I'm going to do is I'm going to keep the original, the last lot of syntax we used up to geom point the same. So penguins as our data, our mapping is going to be flipper length on the x-axis again, body mass on the y. The species is going to be color, so that categorical variable is going to represent by different colors, and we want these scatter points, geom point. But notice here I'm then adding a plus and another argument. Geom smooth is the argument I'm using here, or the parameter I'm using here. And in parentheses, I'm saying the method to use equals LM in double quotes, or linear model. So it's going to fit a regression line. You run that, give us another plot for each species separately. There we go. We can see it's even given us the 95% confidence intervals as shaded areas around. So you can see we've now got three different species, three different regression lines that gives us an idea. Or for those of you not familiar with sort of classical statistical models, least squares regression, it's giving us kind of these best fit lines showing kind of the relationship, the pattern of relationship between flipper length and body mass for the three species. Okay, so that was achieved by adding this geom smooth argument afterwards with method equals LM. So what though, if we wanted to keep the plot where we've got the three different species represented by different colors, but we only wanted one regression line to give us the kind of the overall appearance of the overall regression line for the whole data set and not broken down by species. So we're ignoring species, but we're just still fitting a linear model to the data set, to the whole data set. So we could do that, and the way we do that is, interestingly, by changing the syntax a little bit. So originally, if you remember, we specified in the first set of parentheses after ggplot, we said which data use, penguins, and what the mappings were, our aesthetics. X was flipper length, Y was body mass, and then we also specified that we wanted color to be represented. Species to be represented by color is probably the correct way to say it. But notice this time this has changed slightly, and the color, we've added this extra mapping aesthetic argument, but we've added it in the geom point, in the parentheses after geom point, after that geom point function or method call. Okay, so hopefully you can see how that's different. Above, color equals species was in this first one, and there was nothing in the parentheses for geom point. In this one, we've kind of moved that argument and we specified a mapping argument here for color equals species. Okay, and then we've got plus geom smooth, so that's left that the same. Let's run that and see what that looks like. And there you see, we've just got one regression line. Maybe that's what we're after, or rather than separate lines for each of our 3 species. Okay, so note here the difference was that we've specified this color equals species argument as a mapping under the geom parameter rather than the initial data mapping in the first call to ggplot, essentially. Okay, so notice one thing to notice here. I've made notes so I didn't forget to mention this, is that the syntax for ggplot is similar to using the pipe operator, where we build up our code instructions a step at a time. So we take our data and then we pipe that into the next thing where we ask for the mean. We select certain variables from that data, and then we want the mean from one of those variables, that type of thing. So we pipe each layer, we're kind of piping it into something new, essentially. In this case, though, in ggplot, we're using these plus signs rather than that pipe operator that I've put here as an example that we use when we're using kind of the tidyverse to pipe our instructions. Both of them it's similar syntax. It's achieving a similar sort of thing where we're kind of building the syntax of our code up a layer at a time and making it more specific and complex in some ways. But it's in this case, when we use ggplot, we're using the plus sign rather than the pipe operator. Okay. In some cases, it will be, if you're doing complicated things, you might all in one step use the pipe operator and then embed within that a call to ggplot and some plotting. So you would have pipe operations and then ggplot with your kind of plus symbols, building up the layers of your plot that you're showing on the figure. And the further point to note is that the plus sign comes at the end of the line in order for the correct syntax to be correctly specified. So if I'd kind of put this plus sign down here on the line below and kind of let that line end with a parenthesis, it wouldn't necessarily kicked an error, but when I ran the code, it would have probably stopped here without plotting the geom smooth, the kind of linear model geom smooth parameter. Okay, so worth noting, if you kind of type out your code and run it and it doesn't work quite as you expected, then you may be making these type of little syntax issues where these need to be in a certain place in order for it to work correctly. All right, so we've covered quite a lot so far, but what I thought we'd do is I'll do a final version of this plot. So maybe we'll want to make this a bit nicer, make it publication or presentation ready. You notice here we've got the variable names, body underscore mass underscore. We wouldn't really want it like that if we were publishing that. It's not got a title, and your kind of legend's fine, I guess. But maybe we want to tidy this up a little bit. In order to do that, we can use our, we specify pretty much the same stuff. Here we've got ggplot, data, mapping, geom point, geom smooth. But then I've added this plus sign again and another parameter called labs for labels. And then in parentheses, there are a number of different arguments you can pass to this. I'm saying title, and then I'm passing a string for what I want the title to be, subtitle as well, and then a string for what I want the subtitle to be, and then X and what I want the actual text on the X and Y axis to look like. So I want to tidy it up so it's not got these underscores and it's capitalized. And the same with the color, species, I want it capitalized, and the shape. as well. Okay, this is an interesting one. What I've added here is shape equals species. So rather than each data point, each species being represented by a little coloured circle, we can use different shaped objects to represent different species as well as different colours, and they will pick a default number. It's I think our ggplot has like 7 different shapes that you use by default, and it'll pick the first 3 of those. Let me run that with Control and Enter, see what it looks like, and you can see there we've got a much nicer. We've got a plot here with a title, a subtitle, nicely labelled X and Y axes, nicely labelled legend, and blue squares for Gentoo, green triangles for Chinstrap, and little red circles for Delhi. Okay, so if that was our final plot, you know, that's great. It looks really nice. It looks professional. But what I've not done so far is kind of assign this. I've not saved it as a separate object by using the assignment operator, but we could do that as well. Let me just run that. So you can see here I've used exactly the same syntax that we just ran above to create this plot, but this time I've used the assignment operator and I've given it a name, fig1. So let's run that, and what we did, the picture didn't change, the plot didn't change because it looks exactly the same, but you will notice now we've got it saved as a separate item in our environment, a separate object in our environment called fig1, fig_1, figure 1. Okay, right, another video that's longer than I intended, but this was just to get started by introducing some data visualizations using ggplot. I started with scatterplots because they're probably one of the most common when you have numeric variables, and I use this built-in dataset, this Palmer Penguins dataset, because it's kind of nice and easy, and it's got categorical and numeric variables, so nice and easy to plot. Okay, so this the code that I got on the example that I used, I got that from the 2nd edition of the Arthur Data Science textbook, which is a really good textbook. I was looking for an example of kind of a data set that's pretty good for plotting a scatter plot, and that's probably my favorite textbook for using R, certainly for tidying, wrangling data and creating visualizations. And I obviously found a really good example there. So that's kind of the ones, just to acknowledge, that's where I kind of found a lot of the examples that I'm using here, and that I have used in this video. And I would recommend that textbook to anyone who is trying to teach themselves how to use R. Okay, thanks for listening. I'm going to stop recording now, and in the next video I'll create some other type of visualization with a different data set. Okay, thanks very much.